Oracle released the latest version of the SDK for Java ME, there has been lots of issues with the emulator, especially with 64-bit machines. Right? A lot of we have reported that sometimes the code runs, sometimes the code doesn't run, and in some cases that it just does not run at all. Right? And there is a problem with the emulator and so on. So most of the time I have advised that somehow you find a 32-bit machine and go to the previous version, 3.0, because that seems to be a stable version, it works fine. Solution for this assignment that I have posted, so I talk about the assignment also. I have said that you can either use J2ME, which is you all know, or you can use Android. Right? So you have an option now, and I will talk about how to install Android, what are the things, what are the differences, and so on. If you are okay, I mean, it is okay to use any one of these. So the assignment is, you will need 2 phones in the emulator. That is the difference now. There will be communication between 2 different emulator phones. So, and you need to establish a Bluetooth connection. So on one phone, there would be a Bluetooth server running. So this is one way of implementation. You can use it, you can use some other implementation as well, like a peer-to-peer connection and so on. And you put this in a message and then send this message across to another phone where let's say there is a server running on Bluetooth and this is all Bluetooth. Okay. And this will display it here. So 2 things you need to learn is first of all how to get GPS coordinates from the phone location. So if you are using an emulator, you can actually go to the console, just like you use the console to send a message. There is a console which is called event generator in the emulator. So if you go to the event generator, you can mention a dummy value for lat and lon, and when you enter, it will be sent to the phone, the emulated phone, and in your application you will receive those coordinates. Right? So this is how we get these 2 values here. And the rest of the part is simple. Once you know a sample code to establish a Bluetooth connection, you just send it as a message over Bluetooth and we will display it here. So that is how it is. Any questions about this assignment? So,
we'll form a text, we'll collect these values, we'll form a text message and we'll transfer it to the other, via Bluetooth to the other phone, and it will be displayed as a text message.
As a text message. Yes, so the display is simple. The 2 things you need to learn is Bluetooth, right? And this will be useful. I mean, if you are doing some projects about Bluetooth, or even with the location information, it will be useful for all of you. Okay. So next thing we will talk. I am hoping to finish it because there is not much difference, as you will realize after the end of this lecture, between Android and the previous version of Symbian. Right? So it's almost similar. It's just that the Android is evolving very fast and there are some minor differences. So unfortunately this is almost $4,000, right? So today if you buy iPhone in US dollar it is about 700. Initially so it was $4,000. So only a millionaire can afford a phone. But now the prices are coming so fast that almost everybody can afford a phone. So big difference between till about 2000 something, it was all a closed model. So the manufacturer will develop an operating system, develop a handset, and even the programming language, but never release anything to the actual consumer. So it is a closed model. So if you know about the open system and closed system, open system is something which is like Linux, right? It's open source, not only for evolution, right? So all the websites were full of text, images and lots of things, and we talked about this, the WAP protocol, and we will see about something about that in detail also. So all of these technologies are becoming very good. I mean the internet, the experience that we have on the computer is very good, but on the phone it is still limited, and it is limited because the manufacturer is so overwhelmed and they cannot devote their whole time developing something new. On top of that, we all saw these challenges: resolution, storage, processing power, bandwidth, battery, and so on. So this is a more like an engineer solution. We talked about this in the last class. So WAP is a stripped down version of HTTP. So what they decided, since phone is not smart enough, if you look at HTML, let's make HTML dumb. So they took the HTML, the language, and then removed a lot of tags from it and made it very simple, very stripped down version of it, and they put it as WAP, and then every website developer was asked to develop 2 different websites. Even for Google, there will be one version for internet on the computer, and there is one version in the WAP, right? And this was not scaling up, because you cannot convert every website into a different website and rewrite it again. So this was not a scalable approach. Then came the smartphone. And so some examples of this: Symbian OS is a smartphone, Apple, Qualcomm has its own group. There is something from Palm OS, there is BlackBerry OS and so on. So all of these are smartphones, and they were really capable enough to have a good resolution, good screen, good network interface. And this changed everything. So they said, okay, you don't need to access a WAP website, you can actually access the real website on the phone, right? And so this was a changing point. But still, there was something lacking in all of this. You see, Android is not here, right? So all of these were developing smartphones, but something was lacking, and that lacking part was the openness. So the people in Google thought about the internet model. So the model of internet is nobody owns internet. I think this is what you have also learned as a first sentence when you took computer networks class. Nobody owns internet, right? It's all free in the sense you can access almost any website, and all the pieces of the internet, the routers, the switches, the optical fiber, individual pieces are the same. And that was the model of internet, and that was very successful. Because if you want to send a packet from one location to another location, you just need to send the packet to the next hop, right? And the next hop will take care of the rest of the things, and depending upon the business, so there is still business. Reliance is earning money, Tata is earning money, MTNL, BSNL, everybody is earning money. But the way they are earning money is by charging just the next hop, right? So that is the model of internet. Another thing that they decided is not to have any proprietary protocol for any service. So you know the OSI model, starting from the bottom, physical layer, link layer, network layer, then TCP, the transport layer, and so on. Nobody has proprietary protocol for any of these layers. And that makes it very easy. Because if I want to develop a website or even a streaming protocol, I can look at all these protocols and write my application. So that is what people decide. If we want to make progress in this world of smartphones, we need to have a model where almost everything is open. People should be able to customize. So for example, there is a big battle between Internet Explorer and Firefox that went on for ages. And the idea was Microsoft decided if you buy Windows operating system, you have Internet Explorer. You don't have a choice. And that was the fighting point, right? And there was a case in the court, and finally decided the user should get a choice for which browser it wants to operate. So same thing on the phone. If you buy a phone from a company, you don't have to use their browser. There could be a browser of your choice, and you should be able to install it on your phone because you own the phone. You paid money, and it's your phone now, and you should be able to install whatever applications you want to install. So this is the model of Android. This is the model of internet, and they decided to put it into Android. So in Android, you are not tied to even the browser. If you want to replace the default browser, you can do that. So that's the model of openness. So this is a little bit history. So they decided to create a consortium called Android. A lot of companies joined this immediately. And so this has chip manufacturer, hand manufacturers, software developers, service providers as in Vodafone and Airtel and so on. So they decided to have this and call it Android platform. And this was the first phone, which was actually, it's very late, 2008, right? So this was the first phone. And then the whole revolution started. I think now the maximum share of smartphone is by Android, right? So within 3 years, they captured the maximum thing. So this was one thing. So one thing is to open up the phone software. Second thing was to create an ecosystem of developers, right? So So just like on the PC, once you buy a PC, you write your own program and you can put it on the computer and you can run it. Right? So same thing they wanted to make it enable for people to do on their phone. So if you buy a phone and if you think of a very nice application, you should be able to write it on your phone and use it. Okay? So they decided to have an open environment where developers can come together and develop their own application. Not only that, if you want to use somebody else's application for service, so for example, there is a messaging service, SMS service that your friend have developed, and you want to utilize that, you should be able to do that. Right? So even that is possible in Android. So you can, one application can call another application and use its service. So this is a big distinction. On the Android platform, there is no distinction between native and third-party application. So we saw that in Symbian OS, there are some privileges given to the manufacturer application, some privileges given to the third-party authenticated, and then there are some privileges for your application. It's not like this here in Android. Everybody is on the same platform. So whatever application Google developed will also have the similar privileges as you. Right? So that is one big difference. So the manufacturer will grant the developer privileges of inside access and knowledge of HANSYS internal software and firmware. So you can actually compete with Google if you develop your own browser, and then that browser could be more popular than even Google's browser. So that is the power you get. So how is it different from Symbian? So this image is not very clear, but what you look at, if you want, this is a Linux 2.6 operating system, so it's very latest. And this is how it is run. So there is some security things in the operating system. This is, you can say, as a kernel. Just like we saw the kernel architecture of Symbian OS, this is for the Android platform. So you see all the standard things: memory management, process management, network, I/O, power, and other Wi-Fi, Bluetooth. So all of this will be like a driver. So it's basically Linux, by the way. Right? So if you are aware of the Linux operating system, it's the same. It's not a nano kernel like Symbian. Right? So it's a bigger operating system. On top of that, you see all these applications, A, B, and C. Now the one difference that you would see in Symbian and this is, in Symbian there is one Java virtual machine, and all your application will reside in that Java virtual machine and run. And in this operating system, every application is a different virtual machine. Okay? So in Symbian there will be just one virtual machine sitting here, Java virtual machine, and all application will talk to that virtual machine. Now every application has its own instance of a virtual machine, and this is called dynamic virtual machine. It's basically still Java, but now what happens is this is more robust. If one application crashes, and it crashes so badly that it takes down a virtual machine also, if there is a bug, so that means the whole virtual machine is affected. Now what will happen is, since every virtual machine is different, even if one application takes down one virtual machine, only that will go down. Rest of the things are just working fine. Another difference is, every application becomes a one Linux user, you see. Otherwise what will happen is, you combine in Symbian with all the applications of Nokia and you give one privilege. Right? So it's one set of privilege. All the applications that user writes, one privilege set. Now, for every application, you can have a one privilege set. And that could be different for every application. So you have far more control now to see what every user can do and every application can do. So I will quickly go through what kind of environments are possible. This is a little bit old slide. Now the operating system is going very fast. When I was developing these slides, I was in Android 1.6 or so. Now it is already 4 point something. So you can put an environment to develop. It's a Java programming language. So Java is the basic language, and they are still fighting with Oracle because Java is an open source language, right? Anybody can. And when Android took this programming language, they never had a contract with Oracle, right? So actually they are stealing something from Oracle. So that aside, you can do it on XP, Windows, Mac, Linux, everything. And you are using Eclipse IDE. So there is a plugin. Have you used Android? I mean, has anybody done programming in Android? So it's a simple Eclipse. and we'll see that what to be done. We'll also see what the debugging options are available. So this is a new programming language, as in, so Java, still Java, but there are some changes. It's a new operating system, and one thing I want you to take from this slide is the philosophy is different. And it's very important to understand what is the philosophy of Android. The philosophy of Android is open system as compared to others. And so that means every user gets the same platform to develop applications, and there is no difference between the manufacturer of the phone, service provider, and the user. Everybody can compete with each other and develop their own application, and it will have the same kind of privileges. Another thing is, it is more robust. It is robust because every application has its own virtual machine. So it is a little slow as compared to Symbian. I think you must have realized also, battery wise also, it takes more battery because there are so many heavy processes running in Android. So that is the downfall. And the another advantage of this is every application has its own privilege set. So you don't need to combine 10 applications and give them the same privilege. Right? So you have final control over this. So for those who have not used Android, some of you have already used and they can just ignore this part. But those who have not installed, so basically you need a Java runtime environment. So you need an SDK also, not just the runtime. So what is the difference between runtime and SDK? Is runtime is something that you require only when you execute the code, right? But if you want to develop the code, you need the SDK. Okay, so you need both. And so there is a version of Java which is the new compiler. This is not compatible, so you need to get Java from Sun or Oracle. So that Java is required. Eclipse, you can use Eclipse 3.3 or later. Then, so for example, if you are using Eclipse, I don't think everybody is using Eclipse for the first time, but you just install Eclipse IDE for Java Enterprise Edition. So you get Java built into that. And then you install the Android SDK. So this will give you all the libraries or APIs to develop Android application. And this is most important, the final thing. Install Android plugin for Eclipse, and it's called ADT. So you search, if you Google for this, I've also given you the link. Right? So you will go and then download a plugin that will get inside your Eclipse, and now you can compile, debug, and you can do everything with the Android code. So just like J2ME, you also get an Android emulator. Right? So this is an emulated phone. So if you develop application, you want to test this application, you can use the emulator. You can load application in the emulator, test and debug, and you'll see all of that. And this is a generic device, so if your code runs on this, doesn't mean that your code will run on the real handset. Right? There is still some differences, and so you need to finally go and test with the real Android phone. There is something, so Dalvik is the virtual machine. To differentiate between the Java world and their world, they decided to name it Dalvik. Otherwise, there is not much difference. And it has a debug monitoring service called DDMS. So this will give you access to the processes and threads. So just like in Windows, you can see which applications are running, which processes are running, and so on, how much memory is utilized. You can do all of that thing. Even see what is the heap data. Okay? So if you're dynamically allocating memory, what is the heap data, which process to debug, and so on. You can kill a process. So it's basically a Linux operating system. And whatever you can do in Linux, you can do all the same things here. There is a protocol called ADB, Android Debug Bridge. And this is what they use to connect to a phone and debug the phone. Anybody has heard this term JTAG? Yeah, what is JTAG? Let me ask you. Because I know you would have heard. What is JTAG?
It's an interface, like I have done an embedded system programming that board using JTAG interface.
Right. So table and see its value. You can do the same thing in assembly language. Okay? So if you write an assembly language code which is load, move, and all these subtract instructions, multiply, you can actually step through that code and stop at any point. And that is called a JTAG. It's an industry standard. So no matter from where you buy a processor, like Intel, ARM, AMD, they will all follow the same interface. Right? So if you have a JTAG cable, you can connect it to processor and debug it. Now what happens is when you buy a PC in the computer, you have a processor, Intel processor, they cut the JTAG pins. Right? So even in your phone, there is actually in the processor there is JTAG interface, but they don't give you that interface. They cut it most of the time. So you cannot debug it. But if you buy a processor where you, from off the shelf, then you can insert those cables and connect the pins and debug it. Right? So they decided to have something similar for Android phones. So if a user who wants to debug the phone can actually step through one instruction at a time using this protocol, and this protocol will be supported by all the Android phones and all the Android tablets. Right? So for example, you can do very smart things. You can interact with the file system of the phone. So you can actually log on to the phone and see which files it has got. Typically you can't do this on the phone. You can install Android applications manually. Otherwise, going through the package manager and then installing the application, actually go to the operating system, install application. You can issue shell commands, just like you see in the terminal, do ls and so on. You can do all of those things. Basically, it's like getting access to the operating system of the phone. And then you can do multiple things. Right? On the phone also you can do this. Do you know what is the term called for that? So if you want to have a root access to the phone, Android phone, what is the term which is used? Rooting the phone. And another word is jailbreaking.
So doesn't jailbreak means like something that's illegal?
Yeah, so you rooting, so it's not really illegal now. What happens is, if you do this rooting or jailbreaking, that means you, the third party software, but the warranty is void now. What happens? So the phone manufacturers give you warranty on the phone. 1 month, 2 months, 1 year, whatever. Right? And so that is the warranty period. And I don't know whether you have seen, all the hardware that you buy, there is sometimes a tape connected on the screw. And if you cut this strip, then the warranty is void. The reason is if you cut this strip and unscrew the device, then you can do anything inside, right? And the company doesn't know it. So it will say, okay, we will not take the responsibility. Same thing with rooting and jailbreaking. If you do this, you can actually go to the operating system and do even corrupt operating system. And then it's not the responsibility of the manufacturer or the vendor to repair your phone. Because you have actually done something wrong with the phone. Right? So that is why the warranty becomes void. So it's not illegal. It's just that if you care about the warranty, then it's not a smart thing to do.
But for iPhone, I think jailbreaking is illegal.
It was illegal, but the court gave a decision that it's not illegal. In the sense, so even if you sign that, so the company used to ask you to sign this agreement, just like you accept all the terms and conditions, they would say you will not jailbreak. So finally the court said, the ruling was, you can still jailbreak, and it's not illegal, but it's just that the warranty is void.
The company has the right not to repair.
Yes, so they may not repair your phone if something goes wrong with it.
Same happens with Android routing.
Same thing with Android routing. So the warranty is void.
The same way as machines like opening that sticker is not illegal, but if you do it, it's warranty.
Yes, the warranty is void. So that is the thing.
उसका unlock अंदर से रहा मैंने unlock कर developer registration उससे phone unlock हो जाता automatically.
So unlock is little different. We are talking about the unlock, right? So unlocking means typically what happens is the phone is locked with some service provider. So for example, there are some phones coming from Vodafone.
No, I'm not talking about that unlock. I meant that you start to get all the permissions of OS.
Okay.
That kind of unlock.
Okay. So the standard term that unlock is used for is for service provider connection.
Yeah,
so if you get a phone from, let's say, Airtel, and you have a 1 year contract, then for 1 year you are tied to Airtel, right? And they might give you some discount. And if you want to put another SIM card, like Vodafone SIM card, you can't do that. Because the phone is locked to that network.
Does unlocking this way what the warranty is? Because I think it will, because AT&T will say that like.
Right. So it might. Yeah. So I haven't looked at that. It might take out the warranty. But it doesn't make sense to make the warranty void.
like people who get phones from USA, they're normally locked to some service provider.
Right. So I think those who have already written Android applications and first create an AVD device. Right. So you can say, okay, I want Android 1.6, Android 1.7, 2.0, whichever you want. Right. So you have to create that device, and then that device will be used to run your code in the emulator. And you can use a custom profile for the hardware. So for example, if you want some particular hardware like touchscreen and this and that, you can select all of that to create a special hardware. So this, I think all of you know. And so there is a Hello World application here that you can see. But you basically create a new project, or you can take a sample project and edit it. Right? And so that will be a new project, and that will be the new application. And then it's very easy to run. The standard things you will see when you have an Android file. So you all remember in J2ME, what are the files you typically see? Can anybody tell me? Jar file and JAG file, right? So in that there is some descriptions. So jar file is basically the compiled code and which is compressed. JAG file is all the descriptions. Same thing here in Android, and I think same thing would be even for iPhone, iOS. And so you see this XML file that defines statically what are your capability and permissions you require, right? So you see this XML, it's just that the file format has changed. Rather than a simple text file of JAG, now there is an XML file. But the concept is still the same. You separate out the code, compile code, and some descriptions apart. The descriptions you can edit statically on the phone and give more or less permissions and so on. Another thing is, let's say, these properties, right? What are the build system options and so on. Another folder is resources. So all the screen layout and icon and so on, which is not otherwise part of the code, you can separate it out. And this you can, so if I want to change the icon of my application, I just need to change the file, icon file, and it will have a new icon. Right? I don't need to change the code. So you will see all of these folders and files separately. In the Android, it will typically, if you use Eclipse, these all folders will be created automatically for you. So you don't need to worry about all of these folders. You just compile your code and you will get all these folders. So this is a source folder where you will put all your source code. So you can see all the available targets, and then these are the standard commands that depending upon your installation, you can see which are the AVDs available and targets available. So I am selecting Android 1.6. So this was designed back in 2009. So this I selected, then I gave a name to my application. Then you create a package, so then all your code is at one place. Then you create, so we'll see what an activity is. But basically, anybody knows if you've done Android, what is an activity?
That is like like for desktop application, that's the GUI interface. The component that runs the first and is primarily responsible for the GUI and all the interface.
Right. So it's almost, we're saying the right thing. So it's one of the application, one of the uses the first GUI. But there is little more to activity, and we'll see what activity in technical terms, or what is the definition of activity. Right? So basically you need first activity for Android. And that is a must. So all of these things are compulsory, and you have to do that. Then I am creating an AVD, if you see I am creating a flash disk of 1024 megabytes. So you can tell, so for example, if your code is going to use the flash disk, the flash card, you can mention how much is the size of that and so on. That will give you an AVD which you will use for the emulator. So this is again a different thing, right? This you did not have in Symbian. So you have to mention an entry point for your application. It is not a standard entry point. In J2ME when we discussed, what is your entry point? Start time, start app, or start, whatever was the start thing, right? Here you can actually mention a different entry point. And that is a one more level of customization. That's the only difference. And then this is all standard, and this is all you did for Symbian operating system also. So you have a target, you compile the code, and with that target you run the code in the Eclipse, and you will see the emulator popping up. Once the emulator comes, your application is automatically installed in the emulator and you execute the code. So we'll quickly.
So when I was using NetBeans, there was a default application, Hello World application there. So there was some screen showing that this should be the part of the application. What was that? I mean, is it connected? Because they were showing that this is the start, and then you can go from here to here, and some arrows were there, a default defined pathway.
So this was in the emulator, or?
So it's the control flow of the application.
Okay.
How the control flow. So basically, this NetBeans, the next version of NetBeans, and the current SDK has included a GUI editor for the for the phones also.
Okay.
So that also shows the normal GUI screen that will appear, plus the control flow of the program.
So you see actually the which instruction will be executed next and so on.
No. Like from start, it will go to this form one. From form one, this method it will go to this place.
Okay. In the GUI.
Yeah, in the GUI.
Right. And then you can maybe connect them.
You can just
so
drag one to
So this is what. So this is now the new thing in the Eclipse. So one thing is you can write the code, and one thing is you can actually take the modules and then just wire them, and that will give you an interface. It's easier to do it. It's mostly used by the non-programmers to create an application. I think that's what you're about.
I don't think that a non-programmer will be able to use it because it just connects. All the code you have to write.
Right. So it's when I say non-programmer, doesn't mean he doesn't absolutely know it. It's just that there are different levels of programming. And so this is one of the things. So you can actually create an error. So this is another way of debugging. Right. So if you want to, just like you put printf statements, you can actually put the error things, and you can stop the code. And then if you want to look at some variables, you can look at the variables to debug them. So this is what. So you can launch into the debug perspective. Where is it? This one. So you launch into the debug perspective, and when you compile the code and run it, you can actually start debugging it. Another one is the logging support, and this is very important. I'm sorry you can't read this thing. So let me just see what this. So what this is doing is you saying log dot I debug tab. So anybody knows what a D message is? In Linux. Have you used this command? Then if you go to Linux prompt, type this command and see what happens. Maybe you will need a sudo access.
Is this similar to error level in Windows?
Error?
Level in Windows. So what
It's similar, yes, it's similar. It's log, right? So D-message, so there is, in every operating system, there is a way to create log. And this is very important for every operating system. Right? So what happens is all the Apache server, everything server that you start in the computer system in Linux, they will have a debug or a log system. Right? And that log will be collected at one place and shown to you. So if your computer crashes for some reason, or if there is an intruder, for example, in one of our servers, there used to be an intrusion. People from outside will try to log in or try to break the system, and that information is kept separately. So for example, if you try a super user password more than 3 times on a computer, and every time you fail to log in, right, a message is created in the log saying somebody is trying to attack your super user password. Okay? So all of those messages go into one place, and that is what you see in the debug messages. Same thing you can do in Android. So you can say the log debug, and then if whatever statement you write will go to the log file of Android phone, and it will be all stored there, and it will have different levels of logging. So one is information, another one is critical, right, and something in between. Okay? So depending upon how much is your logging level, if you see, if you want to debug a system, you can even go, so critical means something very serious has happened. So for example, some processes crashed, you will see all that in critical. Or if it's just information that some user has logged in, you will see it in the information. So you can use this debugging to find out what is happening with the system. And you can interact the same way. You can send a geolocation. This is what you would do in the assignment. That you will see the DDMS perspective, just like there is a WMA console and event generator, DDMS perspective. And you can use it to send SMS, make a voice call. So you can actually call the emulator by dialing its number. And you can send the GPS location. So all of these things are possible for interacting with the application. So I think after this you can go, so I will post all of these slides also on the Moodle. You can connect the links, download if you haven't done already, download the ADT plugin, put it in your Eclipse, and then you can, and also download the SDK, and you can write your first application. So after this we'll actually see what is Android operating system. Application is a collection of tasks and everything is called activity. Right? Each of which is called an activity. So basically you can imagine this to be just like playing cards. So you have a set of playing cards, you just arrange them one after another, and if you combine all of these cards, it's your application. And so for example, if your application is to get the one in the assignment, there is a geolocation, GPS location you get, and then you send it via Bluetooth to another one, and you display it on the screen. Okay? So you can divide all of these things into tasks, 3 separate tasks, let's say. Everything would be an activity. You combine all of these activity and then that becomes your application. So each activity within an application has a unique task or purpose. When logically you can then divide the application into activities. And this is a very core thing for Android application, and we'll see why it is so. Typically, so this is not a thumb, this is like a thumb rule, it's not a final rule. You define and implement activity for each screen in your application. So in Java ME also you saw different screens, forms and so on, right? And you can have one screen, then go to another screen and so on. So what you can do in Android is, every time you want to show a new screen, a new UI, you put it into an activity. And then you can move from one activity to another activity. Right? And so what will happen is, let's say in your applications you have 10 activities. So there will be stack where you can put these activities just like you put cards. Right? So for example, you show one activity A1 and then user says next. When he says next, you will put A2 on top of that. Right? And if you go on doing next, you can go all the way to A10. Right? So that is what the user will see. Whatever is at the top of the stack, this is what the user will see. And then when he presses back, let's see, if there is a back control, you will start taking out the activities and go back all the way down to A1. Right? So this is the stack implementation of activities. You can show one activity at a time and then you can move between one and the back activity. So one example of this is, I will show the main, so this is the start of activity. So we'll see the start of application, right? The application is starting. And then after that, you will go to the main menu of the application. In the main menu, if this is a game, you will have the high score activity, gameplay activity, and help activity. So this is how we divided the whole application. Start part, main menu. In the main menu, you show 3 options, and user can jump to any one of these activities, and then come back to the main activity and so on. Right? So this is an example of how you can use activities. Android applications has multiple entry points, unlike Java ME. Java ME just one entry point, and that also if you come again, it's the same entry point. So it was very simplified. Here it is a little complex. You can define in your application what will be the entry point. There is no main function, because you define the entry point. In C and all other languages, in Java, you say this is main function and that becomes your entry point. Now in the Android, there is no entry point. You write your application and you can keep changing the entry points. You can directly go to the exit screen also. If you say I want to go to the exit screen at the first, you can do that. So and you just have to edit the XML file, and that makes it very simple. Right? Just edit. You don't need to recompile the code also. Take the compiled code, just edit the XML file, and you can change your entry. So you can launch a new activity by its last name. This is one way of doing it. So an activity will be coded as a class, a separate class, and then you just say, I want to start this activity. We'll see what an intent is, and then you just mention the class name. Right? So every activity you can put in a separate class file, and they just call the activity by its class name. Anybody knows what an intent is? If you use Android. So intent is an asynchronous message mechanism. This is a new thing which was not there at all in Symbian, and it's a very powerful thing. So you can send a message to the operating system saying, I want to do this. So for example, if you want to make a phone call, you can tell the operating system by sending a message saying, I want to make a phone call. And the operating system will find the right application for you and give you the phone call interface. Right? So a lot of times you see, there is a number shown on the phone. If you click the number, a phone call screen pops up. Right? The way it is done in Android is, when you click that number, it creates a new intent. That intent is a message sent to the operating system. Operating system, now the job is to find the right application to satisfy this intent. And if it's a phone call, it will find out where is the phone call application and show it. If you click a URL, it creates a new intent saying somebody wants to browse the web page. It finds out where the browser is and gives you. Okay? So now what you can do is you can create an application for browsing. Let's say you design your own browser, put it in the operating system. Then you can tell the operating system that whenever there is an intent, it will be matched. Right? So action types for creating intents are action main, action edit. So edit means you edit the text file. So all of these you can do, and that will be a separate intent. So this is a number, action dial. So this is an action, and you can create an intent to dial a number like this, and then so almost similar. You just say telephone, the number, and this creates an intent. The Android operating system will find the right application to dial this number.
In case of Android, you are saying like if I click on a number, it'll ask me whether I want to call the number or message. When I'll call, they will intent and find an appropriate application to call. Well, in case of a Symbian phone, we also do a similar thing, but what is that using? When we click on number, it'll ask me whether you want to call or do whatever you want to do. And if I click on call, it'll call.
Right. So the way it is done, so Symbian operating system can also do it. The only difference is there, if you remember in Symbian OS and Java, you described that you can create an application to invoke some specific type of files. Like say if you want to show an image, you can register it in the registry. Right? So we say, so there is a push registry. Right? So in that push registry, you can mention there is a number, I want to call this application. Right? So it's more static. And this is dynamic. In the sense, our operating system actually sends out the message. And if the browser application is receiving this message, it receives the message and it will go. And at runtime you can change who is going to listen for which messages and so on. Right? So it's the same thing, there are minor differences as I was saying. Symbian can also do it, Android can also do it. The way it is implemented, there are some minor differences.
No need to make an entry in the push registry for this thing.
Right, you just read, but still, you send basically a message. And if nobody is listening for the message, the application will not be launched. So that is how it will happen.
Somehow this is improvising over, better utilization of resources of the mobile over Symbian. Doing this thing dynamically.
Right.
Instead of making
registry and binding it, everything. Right? So this is more dynamic. At runtime you can change a lot of things and this will still work. Since we are little short of time, let me take the most important thing first. And then we'll see how much time. So, this is the anatomy of a life cycle. Just like in Symbian, we saw the life cycle of the entire application. So, this is very primary. If you understand this, then you can write applications. Otherwise, your applications will do something that you cannot expect. Right? So, the way the application is arranged, you see there is on create function. Right? And this what happens is when the application gets created, then only it is get called. Right? So in Symbian, what is the difference? Can anybody?
Start.
On start, and on start will work anytime, right? So even after resuming, you go to on start. But here on create just invoke once. So by definition, in the function, you can know whether you are creating and starting application for the first time or it is coming out of the pause state. Okay? That's one difference. There is something called on start after that, and there is on resume. So on resume is very simple, right? So there is the same concept. Just like there was a pausing and resuming in Symbian, you also do the same thing in Android, right? So they just did the same thing what was there in the Symbian, not difference at all. So you see on resume, so this is resume, and then this is pause, right? And then you go from here to here. After you are paused, you can go from here to here. Right? And then you can keep looping. Pause, resume, pause, resume. There is something called destroy at the end. So when you terminate the application, it is destroyed and taken out of the system. So the only additional thing is this part. There is something called start and there is something called stop.
So might be like if I press the home button, application doesn't get destroyed, but it just goes to a temporary memory.
So pause means you actually pause the application, it is not running. So it is stopped in a way, right? And it can resume from the wherever it has left, right? Now in Android smartphone application, there is another thing which is called start and stop. And what happens is, as you were saying, this is one way of doing it. If you press the home button, your application is not paused actually. It goes into the background. So the screen that you see is little different, right? Whichever the new home screen is or you start a new application. But the other application is still running and it just goes into the background, right? And that background is what, it's not there in Symbian per se. But this is there in Android. So if you do a background thing, so it will go into the background, and then when you make it again come to the foreground, it will come here onto the start, right? And this is how it is done. And depending upon the need, so this is all activity running in foreground. So these are all activities, and you can start one activity, second activity, third activity. It will keep running. If for some reason you start too many applications, like you start one application, second, third, fourth, and now the RAM is limited, right? So you are running out of RAM. The operating system will kill that activity to have more memory. So when you do that, you again go back to create next time, because the application is terminated. So obviously you will in the background. So the operating system will not kill that application which is in foreground, right? Because that is the first application that is being shown to the user. So whichever has gone to the background and it is way in the background. So it's like first application started and you are not seeing it, or least recently used and so on. Right? So it will terminate the application, but what happens is user is not aware of this termination. So user doesn't know that my first application which was started is terminated. So when the user again goes back to the first application, it's immediately started on the create and it is shown to the user, right? So this is how it is done.
So that means suppose I'm just doing some document editing,
right?
I didn't save it, I put it into background,
Right.
started doing something else, my phone runs out of memory, my document can be just...
So can you give me a solution? What must be happening? So that's a good question, very good question.
So the best part we can do is simply dump that application onto a hard disk, like swap space or something.
But there is no swapping as in going on,
Yeah,
right?
so that knows.
So what would you do? Any solution?
Give a choice to the user. Like if it's running out of memory, you can say if
Or at least
something needs to be saved.
give a prompt that
Right, but that is not, I mean, you can do that, but then you're asking too many things for the user to do. You can do it very smartly in the background. What you can do? You can look at this diagram and maybe figure out what must be happening.
we can save the state of the application.
Right. So you cannot save the state of application. So you see, there is something called on stop that is being called. So whenever the operating system calls you on stop, right, on here, on pause, you can write. So for example, your application is editing the document, right, and the operating system calls you one of these methods. You will save it. Save the current state of your text file into the memory. And next time when you get on create, you can look at that file and just show the same thing to the user. And a lot of this thing happens when I look at Gmail on my phone. Right? Gmail application is running, so the phone is running out of memory, it terminates Gmail application. But next time when I go back to Gmail, I just see all my inbox again where I left off. The way it happened is, the application has to go to the disk, right? It has saved its own state. It will take that state and show it to me immediately. So user doesn't know that this application was terminated and starting again. And this is the difference between your programming a computer and programming a phone. So when you write your code now, when all of these method gets called, on stop and something, you just save the state. So the next time it is started, it will start from that point. Here's the whole state, right? Whole snapshot of the memory for you. So the application is not aware of anything like this. But in this particular thing, the user is made aware of it because OS is not capable enough to do all of these things in the background. So the application needs to be a little more smart. So I was talking about, so I will not go into detail about all of this because is the basic part clear, the life cycle. So the only difference is now create method, which always not only when you start the application first time it gets called, and there is a concept of foreground and background. Right? That is the difference between Symbian and Android. I was talking about the intent and activity. So one of the intent action is action battery low. So if your phone is running out of battery, operating system detects it and it sends a message battery low to all the applications. Now the application can receive this message and for example let's say it is playing an MP3 file. Right? So it is playing music, or it's playing a video. What it can do is, you can see since the battery is low, it will stop that playing of music or whatever it is, right? So you can write your application this way, which are now smarter. When the battery is low, you don't do anything which is energy consuming. Another thing is, you can check whether your phone is connected to Wi-Fi or GPRS. If your phone is connected to Wi-Fi, then you connect to the server and download emails. Right? So you can make a decision whether to download a big file or not. If you receive a message saying now you are connected to Wi-Fi, then only you download a big file. If you receive a message that you are connected to GPRS through cell phone, then you don't download a heavy file. Okay? So you can write your applications which will become smarter, and depending upon the condition of the phone. Like you can also receive a message saying the phone is connected to the wall power. It is being charged. When that is done, you can actually back up your phone. So for example, in the latest operating systems, iOS, if I am connecting my phone to the wall power and there is Wi-Fi access, then only it backs it up to the cloud. Otherwise, it does not back it up to the cloud. So you can use all of these intents and so on smartly so that your application is not taxing the user. Even if it is, you might just upload everything or download everything through GPRS and that will incur heavy charges. Right? Or if the battery is low and then you are downloading something big through Wi-Fi, it is not a good option. Right? So you can use all of these smart things to make your application more efficient. This application has its own virtual machine. it has its own Linux account, and then its related permission. So now there is far more granularity, as I was saying. So applications have no permissions by default. By default, when you write your own application, there is no permission. So whatever permissions you want to have should be explicitly registered in the manifest file. So you go to the manifest file. For example, you want to have access to the contacts, phone book. You can mention that in the XML file, and you will get all the permissions. And when user installs this application for the first time, he is asked that this application needs this A, B, C permissions, whether you want to give these permissions or not. If user says, okay, I want to give them, the application gets the permissions for the lifetime. Right? And then the application can keep using it. So this is all happening. And if the user says, I don't want this, I don't trust this application, I don't want this application to look at my phone book, the application will not be installed. It's that simple. Right? So you don't define what is the permission set. The permission set by default is null. You give all the permission and the user will see all these permissions and it will run. So that way it becomes a little danger also. Now what has happened is, there are so many people in the world who are not aware of these permissions or what these permissions can do. Now if they install an Android application and just say, okay, yes, 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 they are so used to saying yes, 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 yes. They will say all yes, and then they will get access, the application might get access to the very confidential information. Right? So that way Android is, on the other side of the coin, is dangerous also. Right? So it's open, but it could also be result. So there are lots of malware and so on coming. So you must be hearing lots of advertising on FM. That if you buy an Android phone, you install my malware detector or spamware detector. It's because of this. Because it's very open to all of these security attacks. Right? So you need either the user has to be smart or you install some other tool like malware detection and so on and save it. So let's stop here. Your assignment is online. So please submit the assignment on time.